On this picture, we see an element that we call it GY element, or gyrators, for example, are two-port elements that relate the input effort to the output flow or vice versa. We have an example of this system, one on the left-hand side and one on the right-hand side. The mechanical one relates the force F1 to the velocity 2, and then relates the V1 to the force F2. In the case of the electrical one, which is more obvious in my opinion, you have that the output E, the voltage is equal to the modulus times the angular velocity. Or you could say that the current that is circulated in the armature of this motor is directly related to the amount of torque that it produces, or vice versa. So these are reciprocal relationships. So the only point here, the only important thing here is that one, they are two-port elements. Two, that this is sort of a similar kind of transformer, but the difference is that this do not relate effort to effort, flow to flow like the gears do, for example. This behaves different. So therefore, there was the need to have another element. But this is in other words, this is a type of transformer, as you would see this way, but it has a different causal marks. Like in this case, you have that the flow coming in here into the GY, that's the input on this side, but the output of this side is this. Yeah. So in here you have E1 is equal to R times F2, and then you have F1 times R equals to E sub 2. And then you have in here E1 times R prime equals to F2, or F1 is equal to E2 times R prime, as you can see here. So this is the way the Girator elements are written in equation form. What I think it should be totally clear by now is that these causal marks have everything to do with the way the equations are written in the different elements. So that's something to consider. Okay, if we do it in the block diagram form, this is what we will see. But this notation that you see on the right hand is much simpler than this whole thing. But that's what you will have to do if you use block diagrams and you have Girator elements. This is another possibility. If you have the causality like that, it means that the E5 is the modulus times E4, and that F4 relates to E5. That's why they call it a cross transformer, because it relates one flow to an effort, or one effort to a flow, respectively. Okay, we have a couple of other elements to talk about. The junctions. The junctions like this one, using the hydraulics example on the left-hand side, is very good because you can see that this would be like like a pipe that has a, a T in there. You could have both sides input to the T, and F sub 3 would be the up. So F1 plus F sub 2 equals F3. On the right hand side, you see an example of a node on a circuit there. And you could say, oh yeah, in here I sub 3, the current on this side, this one, should be the current coming in minus this one. And that's what this would do. So this junction here allows the summation of the currents. And it's like this. In this case, all the voltage is constant. In this case, the pressure is constant, but the flows need to sum because of the junction, because of the connection, I would say. So this is it's called the common flow junction, common effort junction, where all the E's are the same, but the flows will have to sum. I think this one is a good example of this. It's true that the voltage is the same, but this is U. So current here minus this is this current. Flow here minus this. Flow 2 plus flow. That also zero junction. So this is the property of this system. We will examine this later on, and we need to also analyze the one junction when we continue.